Exercise 28, page 57, question number 5 this time. Again, I'm not going to do the exact question in the textbook, but I'm going to do one very like it, and then you can go back and try that one for yourself. The first thing to realise is that we've got here a situation where we need to do a polynomial division. If we look at it, although it's not top heavy, we've got x squared terms, top and bottom. So we can actually divide the bottom term into the top term, and we'll get a whole number if we do that. So the first step is to do a polynomial division, which I've set out here. So if you remember how to do these things, we need to ask ourselves the question, what have I got to multiply the x squared term, which is in the divisor, to get the 2x squared, which is in the dividend? Well, the answer is 2. So 2 goes at the top. So then I multiply 2 by the divisor, which is x squared minus 5x plus 6, to get 2x squared minus 10x plus 12. So then we write down that 2x squared minus 10x plus 12 underneath and subtract it to get the remainder. 2x squared minus 2x squared is gone, which must be the case. Minus 9x minus 10x is plus 10x. Minus 9x plus 10x is just x. 13 minus 12 is 1. So we've got remainder x plus 1. And that's lower in order than the x squared term. So that's where we must finish, and that gives us our remainder. So we finish off by saying that 2x squared minus 9x plus 13 over x squared minus 5x plus 6 equals 2 plus the remainder, which is x plus 1 over x squared minus 5x plus 6. And it's this part here that we now need to go on and use partial fractions to separate out. And then when we get to our final answer at the end, we mustn't forget that it includes this whole number 2 at the beginning. So see if you can carry on now and divide this part into its partial fractions, which is very similar to some of the earlier questions in this exercise. But I will work the solution through on the next slide. So we've got that. The original problem here can be now written as this. And so now, just looking at this part, the x plus 1 over the x squared minus 5x plus 6, I now need to try and factorise the denominator, the x squared minus 5x plus 6, and think of a number that adds together to give minus 5 and multiplies together to give 6. Answer minus 2 and minus 3. Minus 2 times minus 3 gives plus 6. Minus 2 minus 3 gives minus 5. So now I can say that x plus 1 over x minus 2x minus 3 equals some constant a over x minus 2 plus another constant over x minus 3. And now see if you can carry on and finish this off. What I've done is I've recombined the right hand side, the usual method. A times x minus 3 plus b times x minus 2 all over x minus 2x minus 3. Now equate numerators and collect coefficients. So see if you can carry on from there. So what have I done? X plus 1, which is the numerator on the left hand side, equals a plus b lots of x minus 3a minus 2b. Equating coefficients, we get that a plus b equals 1, because of course the coefficient on the left hand side is just 1 lot of x, so that's actually 1. A plus b equals 1, and the second one, minus 3a minus 2b equals 1. So two equations, solve simultaneously. I would probably do this by elimination, multiply equation number 1 by 3, see if you can carry on there through and get the solution. So we add together equations 2 and the new equation 3 to get b equals 4, substitute into 1, and we get a equals 4. So we've got b equals 4, and a equals minus 3. So now we can rewrite our original problem as 2 minus 3 over x minus 2 plus 4 over x minus 3. Now see if you can carry on and finish the answer in the question in the textbook.